Okay, so we have gotten our drug response or our disease level average for the drug group, for the placebo group. We saw that the drug scores were better, but then we checked by this other variable that could be a lurking variable, and we checked to see if those subgroups of people had different scores, and they did have different scores. And then we checked with this graph if the groups were homogeneous, and we saw that they weren't homogeneous. So now we're suspicious of this data. We're now going to do this for the second trial, the second study, where they, instead of leaving these uncontrolled, they made sure to randomize these, which means they have the same number of X in both, the same number of Y in both, and the same number of Z in both. So when you look at what's remaining in the question, we just filled in all those values, disease response for the placebo or drug group, disease response for the X, Y, and Z, how many X, Y, and Z for drug group, how many X, Y, and Z for placebo group. Were they homogeneous? No. Did one group have a better score than the other? Yes. Now for the second study, we're going to do all that again. So I could, this time when I go up here, when I create my graphs, I'm going to do it in the exact same way, but this time just make sure you click for all the stuff, all the columns for the second study. They each have V2 in them. So when you want to look at the fourth response variable, this time make sure you get the one with the V2. So we're going to create the exact same graphs that we just did, only we're going to do it for the second study. I could run through this and do it just like I did. So if I want to make this graph for the second study, I could go up to stats, summary stats, and columns. I'm not going to do this, but just to run through it really quick. And then I would click the second study, which is spelled incorrectly, and then I would click the thing for the second study. So not this one, but version 2 for the second study. That's the column on the right. I could get all my data. I could do that. Then I would have this graph and I could compare it to the old one. But I'm just going to show you, instead of doing that, you can create all new graphs for this section. But another thing I want to show you that you can do is, well, we'll do that one how we just did. Let me show that. There's for version 2. This time the drug and the placebo, instead of having different scores, now in this version they have the same score. You can make a new graph, or you could edit the graph. So let me show you how I'm going to do this. I'm going to check the scores for X, Y, and Z in the second trial now. I could create a new graph and do it. I'm just going to edit this one though to show you the other way. Edit. I'm just going to flip this, and so instead of doing for trial 1, it's going to do for trial 2. And instead of now looking at variable 3 that wasn't controlled, it's going to look at the other column, variable 3, that was randomized for the second study. Then hit compute. So I just changed that graph and it recalculates it. Now it's looking off of the second study's columns. And notice that there are the same numbers of each in this version. And the scores are close to what they were before, but a little different. I got 1.4, 1.3, 0.7 this time, which was pretty close to what they were. So the groups are still different. Z is still the healthy group. But now when we come and look at our groups to see how they're split, I'm going to edit this one to represent I'll make a new graph so I can compare them, I guess. I'm going to recreate this graph for the second study now. Go to graph, bar chart with data. For the second study, I've got to come to V2. I am looking for drug or placebo group, and I'm grouping by the lurking variable. For version 2, that was randomized. I think that's it. So there, I can look at my two groups. For the first study, they were not homogeneous. In the second study, you can see they are homogeneous. They each have 10, 10x, 10y, 10z in the drug group, 10x, 10y, 10z in the placebo group. So even if z's were healthy in comparison to the other two groups, they have the same amount in each, so it should affect them both the same. That's the point of randomizing. I'm going to close this one. This was from the first study. So for the second study, they're homogeneous, they're each 10, and here's the data we're going to enter for all those second study questions. So the first ones were how did the drug group score, and how did the placebo group score in the second study? Let me enter that data. In the second study, the average value of the response value variable for the subjects who received the placebo was 1.1. And for the drug, it was the same. It has no effect according to this study. Before it was, what do we have? 1.2 and 0.9. Now, no difference when we randomize the variable. Now we have to say, what's the average score for the subgroups? I think we had 1.4, 1.3, and 0.7. Let me check that. Yeah, 1.4, 1.3, and 0.7. And then the last thing was how many of each type? Well, it's all 10s. So that's what we're going to do. So how many people, you make that graph, how many people are type X in the drug group? 10, 10, 10. And the placebo group, same, 10, 10, 10, 10. Okay, based on these answers, were the placebo group and the drug group homogeneous in the second study? They were. Based on these answers, does the drug seem to be associated with lower levels of disease in the second study? No. When you actually randomize those people and make sure that the groups are the same, they both got scores of 1.1. You can see here. Second study, no difference in the drug response for the two groups when the two groups were honestly the same. So no, they weren't effective in the second study. So then the question asks, so which is it? Based on your answers from both studies, so I guess it's asking which study seems more sound. Does the drug, the first study said the drug did seem to work, the second study said it didn't. So which one's more accurate? Which one's better? We're going to say the second one because it was homogeneous. That was the appropriate way to take care of that third variable instead of just ignoring it and leaving it uncontrolled. So we're going to trust the second one. So does the drug seem to be associated with lower levels of disease? No. That's it. Oh, I got one right. Amazing. Well, we skipped all the other questions except the last two. So we got those right. That's good. That's how you do it. You could watch these videos and enter all the numbers I did, but I would go through it and make sure that you know what you're doing so that you can use statcrunch in the future for other things. Again, this is time consuming. This took a little while. It's not that hard. You just click the buttons and it gives you what you enter, but you have to flip back and forth between the tabs and it can take some time. So just be aware of that. It's a shorter quiz, but leave yourself some time to do it. Okay, good luck with that and let me know if you have any trouble. See you in class.